are numerous ways of doing this question, and I'm going to talk about three, I think. So, method one, right? If you're really on top of these simultaneous equations, then what you want to do always is like do the least amount of work possible. And to do that, we just have to make some numbers the same, okay? So if I multiply this second equation by 3, then I make it 3x plus 6y is equal to 15. I have to times each term because it's like I'm putting a bracket around it. So that's why when you expand the bracket, you multiply both of these, and you also have to times this right-hand side. So now I can subtract them. Okay, that's standard practice simultaneous equation. If we add two sides together, then it's still going to be balanced. It's like a set of scales and you're combining them. The same goes for if you subtract from these sets of scales. So we subtract them, these cancel, and we're left with y here, y equal to 3. Nice. And then all we need to do is substitute that back in to one of the equations, x plus 2 times y, which is now 6, x plus 6 equals 5, and therefore x equals minus 1. So that's our answer. Could put it into the top one. It's just a little bit more complicated. There's bigger numbers, but we'd get 3x plus 21 is 18. 3x is minus 3, therefore x is minus 1. So that is approach one, quickest way I would say. Let me look at approach two, because you might be someone who, when you get taught this, you're like very much focusing on this one here, because often this is where the sign difference is in these equations. They don't tend to make it like minus x here. So you might just get into the habit of learning to deal with it by dealing with the second one. Now you can do it. We just have to make the numbers the same again. So this time we have to do two. We have to multiply by two things. We have to multiply this one by 2 and this one by 7. That will necessarily make these two the same. Okay, because they're both going to multiply to give 14. So we're going to get 6x plus 14y is equal to 36, and then 7x plus 14y is equal to 35. Now I'm actually going to take this and I'm going to write the 6x one below because it will just make it a little bit easier to subtract, because then I'm going to get a positive x. So you can do that. You can decide which way around you subtract them. So now I'm going to get x equals minus 1. Just like before, put it back in. Minus 1 plus 2y is 5, 2y is 6, y is 3, etc. Right, last method. Worth seeing this method, even though it's not a great one here, and that is to use the idea of substitution. Often when you learn simultaneous equations, you learn this is called elimination. You learn these methods, but we leave substitution. And it's nice to see it, especially when you get onto more complicated maths, you're like ready for it. You're like, yeah, I know substitution from this. And sometimes it has its advantages. So for substitution, we can make x the subject of the second equation. I would advise using x rather than y because there's a number in front of the y. This is the only reason why I'm using substitution here, because we have an x by itself instead of like 4x and so on. So x is 5 minus 2y. What we can then do is replace this x here by this x here, and hence 5 minus 2y. So without having to subtract or add the simultaneous equations, I can create an equation in terms of y. Now it is more complicated because I've got to now expand the bracket, simplify terms, but hey, it works. 15 minus 6y plus 7y is 18. That means I've got 15 plus y equals 18, and hey, again, I get y equals 3. Substitute it back into this one here, and we'd again get x equals minus 1. So I know I've gone into quite a lot of detail. Yeah, you might not watch, well, if you are still watching, then obviously watch the whole video. But this is the quickest way, but it's good to see other methods. Keep practicing simultaneous equations and developing a good understanding.